So this one, just looking at a practical example for the parabola. Okay, so if we look at this here, there's our equation, h equals 0.5 plus 4t minus t squared. So a cricketer hits a ball and it flies through the air along that path. H is the height and t is the time. Draw a graph of the function of t of the time, and we're going to do 0 up to 4. Okay, so in order to do this, I just get a number plane up. There's our number plane. Now, the thing with the number plane, when we're doing a number plane, we do need to make sure that when we do a practical example, we can see that the time has to be positive. So you need to make sure that when you do this, you rub out what's on this side here, because the time has to be positive. The height could be negative because it could be below ground level, or it could be positive above ground level. So this is your height and this is your time. So if we're doing a table of values here and we have time and we have the height, we're going to go 0, 1, 2, 3, 4. So on that number plane there, you can see we will have 0, 1, 2, 3, 4. There's 5. And the heights will go to, so we're just going to calculate them. So if you put the values into this here, so you go h equals 0.5 plus 4 times 0 minus 0 squared, which gives you 0.5. So the first one's 0.5, and then you get 0.5 plus 4 times 1 minus 1 squared. So that's 3.5, because 4 minus 1 squared would give you 3. And then it's, so that would be 3.5. The next one, h equals 0.5 plus 4 times 2 minus 2 squared. That's 8 minus 4, which is 4. So you end up with 4.5. And then you go h equals 0.5 plus 4 times 3 minus 3 squared equals 12 minus 9 is 3. So you end up with 3.5. So we're coming back down again in our height. 0.5 plus 4 times 4 minus 4 squared, which gives you 0.5. So it's definitely coming back down. So let's plot those points. So the first one is 0.5. Now they go all the way up to 4.5. So we'll call that 1, 2, 3, 4, 5. So, and I'll just plot it. So we go 0, 0.5, across 1 up to 3.5. It's that one. Then we go 4.5. So we go 2 up to 4.5. We go 3, went to 3.5. And so I've done that, that, and that. And then we come all the way down to 0.5. So it's very, very symmetrical. And you can see it is a parabola. If you put in 5, that's 0.5. Wonder what would happen if you put in 5. You get 0.5 plus 4 times 5 minus 5 squared. So 0.5 minus, that would be minus 5, which is minus 4.5. So it's coming down here at 5. So it's going like right down there. So somewhere down there, not necessarily at 4, it's going to intersect the axis. But they only wanted it sketched up to 4, so we'll leave it at that. So sketch it up to 4. Okay, so looking at this, draw the graph from 0 to 4, done that. At what height was the ball when the cricketer hit it? So that's where it starts from. So it's going to be at height 0.5 meters. From the graph, estimate the height of the ball after 2.5 seconds. So after 2 seconds, it was at 4.5. After 3 seconds, it was at 3.5. So 2.5 seconds somewhere in between. So if you were going to estimate it, you'd be getting it from the graph. So basically, that would be approximately somewhere between 4.5 and 3.5. So it's approximately 4, okay? What we could do is just put it into the formula, and that would help you with your estimation, because it's 4 times 2.5 minus 2.5 squared. And if we did that 4 times 2.5 minus 2.5 squared, you end up with 3.75. So you could use, you could do the estimate of about 3.8 meters, and you could get it from, because you've done it algebraically, you just don't have to let them know that you've done it algebraically, but you can still use the algebra to work it out. What is the maximum height of the ball? So the maximum height is its highest point. So the highest point it reaches is 4.5 meters. You can see that there, and it's after 2 seconds. When did the ball reach its maximum height? After 2 seconds. How long was the ball in the air after it was hit? So for how long was the ball in the air after it was hit? Really, to answer this question, how long was it in the air after it was hit? It was in the air here, here, because it hit about 0.5 above ground level, all the way to when it hits the axis again. So the only way that you could answer that is you can estimate what that point was when it hits there. So we know that this point here is at 4, so it's sometime after 4 meters, but it's not very far. It would be about approximately like 4.1, 4.27, and that's just an approximation. Okay, we're just going to look at a second example. A movie theatre has 200 seats. Each ticket costs $8. The theatre owners are currently selling all 200 seats for each session. They decide to increase the price of the tickets to see if they can increase the income they make per session. It is assumed that for $1 increase in the ticket price, there are 10 fewer tickets sold. A graph shown, so the graph is between an increase in ticket price and the income as shown. So down the bottom, that's the increase in the ticket price. So this is the increase in the price of the ticket, and this here is the income shown. Okay, what ticket price should be charged to maximize the income? So if you want to maximize the income, okay, that would be the maximum there. That's the maximum income. So that means that there would be an increase of $6. So what do you think you would charge? So at the moment we are charging $8. So if you increase it by 6, you end up charging $14. Okay, what is the number of tickets sold when the income is maximized? So if you charge $14, okay, and you're going to get an income, so the income is, what is that number there? Okay, so these squares, there are 5 squares there. And if you look at the difference between the 2,000 and the 800, 5 squares will equal 200. So that means 1 square equals 200 divided by 5, you get 40. So if you want to maximize your profit, that each of those is equal to 40, and there are 1, 2, 3, 4. So that's the 4th one. 4 times 40 is 160. Yep, so it's 200. Yeah, each of them are 40. So if you went up 160, then you would be, so if you add that onto 180, you get 0691. So that means that the income is 1960. Yeah, so if you do, you're going to charge $14 and you're going to get an income of 1960. If you divide that by 14, you get 140. So there'd be 140 tickets. It's 140 tickets, $6. Okay, the cost of the theatre owners of running each session, the cost is $500 plus $2 per ticket sold. Calculate the profit earned by the theatre owners when the income earned from a session is maximised. Okay, so if you sold 140 tickets, that would be 500, and then 2 times 140, because that's how many tickets you sold for the maximum one. So 500 plus 2 times 140, you end up with, it'll cost you $780. So if you want to get your profit would be how much income you get in, which is the 1960 minus 780, and the extra money left over, which is 1180, that will be your profit.